everyone, and welcome to SQL Server and Azure Virtual Machines Reimagined. I am Pam Lahoud, and I am a program manager on the Azure Data SQL Enterprise team, and I'm the lead PM for SQL Server and Azure Virtual Machines. And we are excited to bring this presentation to you today. We want to talk a little bit about what it's like to run SQL Server in Azure VMs. Some of the great value add you can get from running your SQL servers in Azure, as well as some of the differences and best practices and things you need to follow when you're running SQL Server in Azure VM. And I'd like to hand it off to my colleague Aditya to get us started today.
Thanks, Pam. Thanks for that wonderful introduction. And hey, everyone, my name is Aditya, and I work with Pam, and I'm also here to talk to you on how to run SQL Server on Azure Virtual Machines. We are here making that running of SQL Server in Azure Virtual Machines pretty exciting, and I want to talk to you all about it. So let's get started here. So you know, right? So you have seen this, and we are saying this everywhere, that SQL is everywhere, which essentially means we have built a modern platform with SQL Server 2019. This is, you can take this, you can put it in the virtual machines in Azure, on the competitive clouds, and even on the on-premises. You can run SQL on Linux right now, so which is extremely exciting, and you have not only on Linux, but also on containers, which makes extremely easy for the portable and consistent with the today's modern data platforms. We are also running, you have containers, you have to have Kubernetes. So essentially, we built SQL which will run on Kubernetes, and even in Kubernetes, you can build entire HA platform of SQL Server. Now, you can run SQL Server on virtual machines. Let's talk about this more. While we are talking about this more, let's also talk about few other offerings that we have on Azure. That is SQL managed instances. It is extremely good for if you are like lifting and shifting off entire your workload, and you want to come to Azure, and you want to have Microsoft or Azure manage of entire instance. This is the best way you get there, and you can manage, you can let Microsoft manage entire instance of yours. But if you want to re-architecture, and if you want to get the entire power of Azure SQL DB, you can put that entire stuff into a single DB, and Microsoft will take care of it. Azure SQL managed instances and Azure SQL databases are the PaaS offerings that we have in Azure. And last but not the least, we are extremely excited. We recently made it as GA, that running SQL Server on Edge. So it's all about IoT, and you can have SQL Server on the Edge platform. Now, today we are focusing extremely on SQL virtual machines, and why you have to run, or let me put it this way, how Azure is the best place to run SQL Server on virtual machines. So as I said in the previous slide, Azure SQL managed instance and Azure SQL database are the PaaS offerings, or platform as a service offerings of Azure, whereas SQL Server on Azure virtual machines is a IaaS offering. What is an IaaS offering? Like, we give you infrastructure, you run your own software on it, and we'll take care of the infrastructure, you take care of the software. So that's what is IaaS essentially. And SQL, why Azure is, why am I saying that Azure is the best place to run your SQL Server on virtual machines is, we are just not calling it as IaaS right now, we are calling it as IaaS++. Let's see why I'm calling that. That is because we are here, and we are right now providing many feature sets for the people who are running SQL Server on Azure virtual machines. Like, what are the features that we are providing? There is entire comprehensive feature set that I'm going to talk about. But before I talk about this entire comprehensive feature set, I really want to cover these 3 points. That is dashboard view of VM awareness. What does that mean? So let's say you are here and you are running and virtual SQL on virtual machines, and most of you guys are already on the some part of the cloud, and there will be web applications, there will be application servers, there will be shared servers, there will be database servers of different databases. There will be PostgreSQL servers, there will be SQL Server servers. Now you have to differentiate, and you want to know what is your database form, or you also want to know, give me all the virtual machines in which are all the virtual machines where SQL Server is running. Today, if you go into any other cloud, you can do this or you can do all of that, but you have to do essentially tagging and everything to get there. But because we understand what you essentially want, we created a unique dashboard, like where you go there and you can see all your SQL virtual machines, their properties, everything in one dashboard. And we also have a dashboard called Azure SQL, where you can go to Azure SQL and you can see different managed instances, SQL DBs and SQL virtual machines all at one place. So that's it. Though it sounds simple, it's a very good feature when you look at broad. There is simple license conversions. So when you self-install a VM, right? You understand that the licensing part of SQL Server is extremely tricky. And when I'm saying tricky, it is for making you guys multiple options. So you take multiple options to leverage SQL Server more. How do you leverage them more? You need to have it to a way to convert from one license to another license. Let's go. I will talk more about licensing in the future sites, but to convert from one license into another licensing, the easiest way you can get to is using simple license conversions that we are providing through SQL IaaS Agent Extension. Also, now there will be most of our enterprise customers like you guys are running SQL Server using software assurance today. Now you have to be compliant, like there will be audits that you have to be compliant, like this using IaaS Agent Extension. Let me talk more about IaaS Agent Extension in a bit, but using IaaS Agent Extension, the biggest thing that you get is you will be straightforward compliant because you are choosing the right license for your virtual machine should have at that point of time. Now, what are this? Like, how am I going to get all this? You're going to get all this by putting a piece of software called SQL IaaS Agent Extension in your virtual machine. So how to get it, like how to get the software, let's discuss more in following slides, but think about this way. IaaS Agent Extension is a piece of software that your virtual machine will have, which will enable all these feature sets apart from this VM awareness, license conversions, and straightforward compliance. And this is unique to Azure. Now, when I was talking here on simple license conversions, let's talk more about what are those license aspects. The software benefits for SQL Server, especially for Azure virtual machines, are as follows. Let's say you have a primary virtual machine. You are configuring your high availability disaster recovery setup in the Azure, and right now you configured one primary in Azure SQL in Azure virtual machine Now you would have a high availability server, a disaster recovery server for free if you run a primary server in Azure. What do I mean by high availability? What do I mean by disaster recovery? Let's say you have a synchronous replica, it's a high availability. If you have a asynchronous replica, it's a disaster recovery. Now, because you are running your primary in Azure, we are giving you AHA and a DR in Azure for free. When I say free, what is free? The SQL licenses for that for HA and DR machines is free. The compute will be still be charged. Now, you also because we love our customers, we also give advantage to the people who are running in on-prem. What is the advantage? We are making your journey towards cloud easier. How? We, if you have a software assurance and you are running your primary in your on-prem data centers, you can run your DR instance in Azure for free. That's exciting because if you run your DR server in cloud, you essentially can test your databases, your failover stuff, and your journey towards cloud will be extremely easy. I know there are SQL Server 2008 versions out there still. I understand upgrade takes a lot of time. So as you know, the security updates with the Microsoft discontinued the support for it, but you can still buy the extended support for it. But if you run the same environment in Azure, you that extended security will come to you for free. We are making why we are doing this essentially helping you to lift and shift your entire infrastructure to Azure such that we take care of your security features and even for SQL Server 2008. Now we talked about IaaS agent extension. Now how to get to this IaaS agent extension? We have this IaaS agent extension on Azure since for a while, but we understood that there are so many subscriptions and there will be so many VMs which will be running SQL Server, and it is pretty hard to go and find and register all of those SQL servers with the IaaS agent extension. So what we did is we created if you go to SQL, I will try to demo it during the demo time. But if you go to Azure SQL Virtual Machines, you would see a magic button we call inside. We call that is Azure SQL Server VM registration button. If you click it, it opens up a dialog box. You give a consent, and if you register to this feature, we'll take care of the rest. So what we are going to do is we are going to copy the binaries of SQL IaaS agent extension into all the virtual machines where SQL Server is present in that subscription. I really want to call this out loud, that change to data privacy policy to shield SQL restriction data from audit. I really want to call this out and I really want to read it as there in the slide because this is a very important point to make. Though we are adding this IaaS agent extension, our intention is only to provide you the comprehensive feature set and the benefits that I have spoken earlier, not to audit, not to do anything. But if you really want to audit, if you want to audit your environment, you can give us an advance consent such that we can go ahead and do it for you. But by default, we are not going to do any kind of audits if you are having the SQL IaaS agent extension in your virtual machines. So what you have seen there is the portal way of doing it. You can do that through CLI, as you have seen here. We are going to share this deck and you can get these commands. And this is the important point I really want to talk about. That is, this IaaS agent extension comes with two modes. One is lightweight mode and another is full mode. What are these modes again? The reason that the lightweight mode is the default mode that we enable whenever you run this automatic SQL VM registration. But for the full mode, you have to go and do it manually per VM. Why do you have to do it manually per VM and why we are not doing is because when you turn on the full mode, we will restart your SQL service to add the login into your SQL Server, because with full mode, we are going to explore multiple features. I'm going to show you through a demo. That's the reason why I'm keeping all the suspense for later. But with full mode, you're going to get multiple features where we need more access of your SQL Server. To get there, we will restart your SQL Server. So please do enable full mode only when your production database has downtime. But by default, we are going to enable lightweight mode on your machines. And lightweight mode doesn't have any kind of performance implications. All it does is it will wake up and it will see what version of SQL Server you are running, and it will let us know. That's it. And that is only to enable the license conversions and compliance features. Nothing more than that. Now it's time for demo. Let's go and do some demo of this feature set that I have talking about, and I will also show you where that button resides. So this is the VM that I have created for the demo purposes way before. If you go, this is the Azure portal, and if you go to SQL virtual machines in the Azure portal, these are the different SQL virtual machines that we have. And if you see here, this is automatic SQL VM registration, which is out here. If you click on it, it will open up a dialog box, and you check your subscription, you accept the terms, and you register, and off you go. You need not do anything. You need not run any CLI commands or do anything. And what it will do is it will take care of all the VMs that are there in the subscription now. All the VMs has in all these virtual machines which has SQL Server running on it right now, and also the future VMs you might create in the subscription in future. So it is one-time activity per subscription, nothing more than that. Now let's talk about what is the full mode thing that I'm talking about, right? So now let me get to my VM. Yeah, so this is the VM that I'm talking about. If you see, when you go to virtual machine, there is this virtual machine and there is the SQL virtual machine. This SQL virtual machine you get, let me go and let me show that to you also. If you go to virtual machines, you will see storage again. You will see storage config test AD Badram. It's a virtual machine. It's not a SQL virtual machine. Now, if you click on this, and if you go and go to SQL Server configuration, and if you click on manage SQL virtual machine, this dialog opens. If you can directly go and type SQL virtual machines and access it like how I did it previously, or you can do it that way. Now, by default, because I want to show you guys all the full features, this virtual machine right now is in full mode, but by default, you would see only this, that is configure and the SQL Server license. You will see this part of it. What does this part do? As I was explaining previously, you can switch your licenses from pay as you go to Azure Hybrid Benefit to HRDR. Like very quick 30 seconds of what pay as you go means is pay as you go, as the name suggests, it's the licensing that you would do if you don't have a software assurance. And even if you have a software assurance, you would do it if you don't want to use software assurance for that virtual machine. But if you already have software assurance purchased, which most of the enterprises do, all you need to do is once you have installed your self-installed virtual machine, you need to change it to Azure Hybrid Benefit, and we will be rating you, we will be charging you as your software assurance, not as the pay as you go. And as I mentioned, there will be a DR machine which is free. There is a HA machine which is free, which essentially means, let's say you created a DR machine in Azure, you need to come, you need to install this extension, and you need to say, hey, this is a DR machine for me, please. And when you say that and give your consent, we'll take that consent and we will not charge any licensing for you. That's pretty much about licensing. Now, You can also tell us what is the word edition of the SQL Server that you're running. You need to. It's pretty much self-explanatory. Self-explanatory. You need to change the edition here, but you have to change your edition manually in the. Also, you need to change there. Come here and change the edition here, such that we know the edition that you are running. We also. This is all the lightweight mode. Now coming to the comprehensive feature set that I'm talking about, you get this storage configuration. You can extend the drive and you can say, hey, I want to add this many IOPS, and we will clearly tell you, okay, this is for this virtual machine, the number of IOPS you are adding might be desirable or might not be desirable. You might not get the performance that you're trying to get, all that. And Pam is going to show you how all the storage configuration stuff. But the rest of the stuff is security. The security stuff. I know, like, I'm a DBA myself, and if you want to change, there are many in my past companies where I was working. Most of the SQL servers were not running on the default port. You want to change your port? Oh yeah, you can change your port directly from here. You want to apply your patches? When I say patches, I will be extremely clear here. We are only talking about critical security updates for Windows and SQL Server. Those are very, very important. You have to be compliant for it. We are going to enable those automated patching. And if you give us the schedule and the downtime, we will go ahead and apply those patches to you, apply those patches for your virtual machine. And backups, Pam is going to talk more around these backups. There are this high availability preview. This is the preview that we are giving to you to configure always on availability groups and entirely through portal. Now, the biggest point to note here is all these features that I was talking about since for a while is for free, and you get those features only if you enable SQL IaaS Agent Extension. Why? The reason is that's the only way we can help you manage your virtual machines. So if you install SQL IaaS Agent, if you register for SQL IaaS Agent Extension, we are going to help you with all these features that I just spoke about. Having said that, I will turn on this to Pam, who would be talking on performance. Pam, take it away.
Okay, thanks, Aditya. So let's talk a little bit about performance of your SQL Server running in Azure Virtual Machine. And this is going to include some conversations around sizing, choosing the right VM, and configuring your VMs for running SQL Server in Azure. So let's start with the different virtual machine types that are available in Azure. We have many different series of VMs available to you in Azure, and so it can be very confusing when you're trying to figure out which one of these VMs should you choose for your SQL Server. So many of these different series have different aspects of them. Some of them have more memory, some of them have focus on storage, some of them are general purpose, some of them are more for like high intensity compute applications or things like graphics processing. Some of them are very specialized. So what we're going to focus on are the ones that we generally recommend for SQL Server workloads. So the one that we find ourselves recommending most often are the memory optimized virtual machines. The reason that we often recommend these is SQL Server tends to be a memory intensive application, and we generally recommend a 1:8 core to memory ratio for most SQL Server workloads. Although for data warehousing type workloads, you might have to go even higher. So the machines that often have this kind of ratio of high memory to core is the memory optimized. So this would be your M series and your E series VMs. So we prefer these VMs for most SQL Server workloads, particularly resource intensive SQL Server workloads. As a more entry level virtual machine, some of the general purpose machines, typically the D series machines, are also appropriate for your basic SQL servers. These tend to have lower memory to core ratios, but this might be okay for basic, like say like a website backend or like a decision support system, something that's not like high intense OLTP or large data warehousing workloads, just kind of a basic SQL Server workload. These general purpose machines can fit the bill for many of those, especially in the lower core counts, 4, 8 cores. And then it's worth mentioning these storage optimized VMs. So for some workloads, these can actually be good as they have local high performance local storage, SSD, NVMe in some cases. And these can sometimes be good for certain workloads. It's much more specialized though, or hybrid workloads where you have other applications running on the system. So for most of your SQL Server needs, you're probably looking at E series, M series, or D series VMs. So that's just the series. And then where do you go within there? Well, within those series, you have different levels of core counts, and you'll find different ratios of core to memory and core to storage. What we find for our customers is that many times, because of the intense needs of SQL Server workloads for memory and storage, many customers are not able to find the right ratios of core to memory and core to storage. Particularly for, like I said, data warehousing type applications where you have a lot more higher memory and higher storage needs. Also in these low core count machines, 4 cores and 8 cores, we have good general purpose VMs, but we don't have great VMs that have a lot of memory and a lot of storage throughput at those lower core counts. So one thing you might find yourself looking into is these constrained core VMs or constrained vCPU VMs. These are VMs where you get the memory and storage of one of the higher end VMs, but you only have to pay SQL Server licensing costs for a smaller number of cores because we constrain the cores. So for example, looking at this standard M3216 MS, what this means is you get the memory and the storage of an M32 system, but you only get 16 cores available, which means you only need to license 16 cores for SQL Server. So this can be a great cost savings for you if you have one of these workloads that's heavy memory or needs a lot of I/O throughput, but you don't need a lot of cores. So these work really well for some more memory intense SQL Server workloads. So constrained cores can help you minimize your licensing costs while still getting the performance that you need. So we've talked about the virtual machines. Let's talk about storage. The way you think about storage in Azure is a little bit different than you're probably used to thinking about it on-prem. Most customers buy themselves a big fancy SAN device, a large array that has a huge amount of IOPS and throughput, fancy caching. Maybe it's fiber attached, so it's like the fabric itself is super fast. So you have this investment on-prem in this, a lightning fast storage device, and then when you need to build a SQL server, you're not thinking about how much I/O throughput do I need. You're basically just carving out some storage on the SAN and attaching it to the SQL server, and you're getting more than enough I/O throughput to sustain your workloads. When you move into Azure, you are actually paying for storage by the IOPS and the throughput numbers. So you really have to think about sizing storage, not so much by capacity, but by throughput. You have to think about the bandwidth, the IOPS and the throughput that's available in that storage, and will it be enough to meet your needs? So you really kind of have to flip the script with how you're carving out storage when you're moving to Azure VM. So your options for storage in Azure are going to be basically premium and ultra SSD. The standard HDD and SSD are not going to provide the I/O and throughput you need for a SQL Server workload. So don't even look at those. Start straight with a premium SSD. We generally recommend P30 as a good drive to allocate. It's got a decent amount of IOPS and throughput for most workloads. And then we also offer Ultra SSD for sub-millisecond latency. So if you have a very I/O intensive application that is very sensitive to I/O latency, then you would look at Ultra Disk. Now, it's also important to note that the limits for IOPS and throughput are set not only at the disk level, but at the virtual machine level as well. So what you see on the slide here are the caching and I/O limits for a series of virtual machines. So these would be some D-series virtual machines. And what you can see here is the total IOPS and throughput that are available at the virtual machine level. So how much IOPS and throughput you get in your VM is a combination of the disks that are attached to it, be it premium SSD or ultra SSD, as well as the cap at the VM level for how much I/O and throughput that it's capable of. Now, what you'll notice here is highlighted in red, we have this cached and temp storage throughput. This comes straight out of our documentation, by the way. This comes right from the D-series documentation. And then you also see this uncached. So what's the difference, cache versus uncached? Well, this is leveraging a feature that's unique to Azure, which is Azure Blob Cache or ABC Cache, or you might also hear it as host caching or read-only caching. So this host VM caching is something that allows you to get much better I/O and throughput performance in your virtual machines by providing a local cache that's close to the VM. So normally these premium SSDs or ultra SSDs, these are remote storage that's attached to the VM. And that's where you're probably going to put your data files and your log files. But by having this host caching enabled, you can get first lower latency because the cache is closer to the VM, it's local storage. But also you can go above and beyond the normal remote storage limitations on the VM. So you can see here for this circled VM, the uncached disk throughput is 12,800 IOPS or 192 megabytes per second. That's how much I/O and throughput the VM is capable of. But if you turn on caching, the VM host caching, you can go up to 16,000 IOPS and 128 megabytes per second of throughput above and beyond, in theory, above and beyond what the remote throughput and storage offers you. So this all depends on how much you can leverage this cache. So if you had a 100% cache hit ratio, you could just add those two numbers together and that's what your total throughput would be. In reality, you're probably not going to get 100% cache hit ratio. You know how the buffer pool works, same kind of a thing. So you won't get the, you won't be able to add these numbers together perfectly, but you will get a boost in performance by turning on this read-only caching. And this is what we recommend for SQL Server VMs. So we're seeing a minimum of 27% performance improvement by just turning on this read-only caching. Of course, your mileage may vary, but this is what we got in our own TPCC HammerDB benchmark testing that we did. So this is something, we're going to talk a little bit more about this, but this is something we definitely recommend that you turn on when you get to your SQL Server up into Azure VMs. So the way you would enable this is by looking at the disks in the Azure portal when you're managing your virtual machine, and you can change the host caching. It can be read-only, read-write, or none. What we recommend is for data drives that you set this to read-only, and for drives that host log files, transaction log files, that you set it to none. Transaction log files can't really benefit from this read-only caching because they're doing sequential writes, so the read caching isn't really going to help them, and the read-write caching isn't beneficial for those. And in fact, there can be consistency issues there. So you want read-only caching on your data drives, no caching on your log drives. So the other thing that's important when you're configuring storage for an Azure virtual machine is that the capacity of each individual drive, the premium SSD, the P30, for example, is fixed. So I think the P30 is, I'm going from memory here, don't take me on my word for it. I think the P30 is 5,000 IOPS. So let's say that your workload needed 10,000 IOPS. If you need 10,000 IOPS, then you need more than one P30 drive. So you can take two drives and put them together into a single storage pool, and then you're able to stripe across those two drives and get the capacity from both drives. So instead of having 5,000 IOPS, you'd have 10,000 IOPS across the two drives. So generally what we recommend is that you create storage pools to stripe across multiple premium SSDs in order to achieve the IOPS and throughput you need. And then you just need to make sure that you don't add more drives, then you have VM level capacity, because remember, there's a limit at the VM level as well. And so the important thing to note for the storage pools, and that's this little animation that's playing in the background, is that however many drives you have in the storage pool, you need to make sure that the number of columns, this number of columns setting on the screen here, is set to the number of disks in the storage pool. That's how you can be sure that you're actually striping across all the drives and getting the full capacity versus just stringing them together and having increased storage capacity but not increased throughput. Okay, that was a lot, right? So I talked about read-only caching, I talked about different sizes of disks, different sizes of virtual machines. There's a lot here. So one option is for you to just let us do this for you. So if you leverage one of our marketplace images, the IaaS extension that Aditya was just talking to you about has a feature where it will automatically configure storage for you according to the best practices that I just outlined. So this slide is showing you a part of the wizard that you would go through if you were creating a SQL Server VM from a marketplace image. And what you can do here is you can just say, okay, I need 10,000 IOPS. I want to use P30 drives, and I want to have, how many disks do I want to have? So here I said, okay, 2 disks, please, to get my 10,000 IOPS and my 400 megabytes per second of throughput. And it tells you right here, okay, we're going to create this storage pool for you. It'll have 2 gigs of storage, 10,000 IOPS, 400 megabytes per second. Then we're also going to create a separate log drive, and we're going to put that on a single P30 with just 1 disk, 5,000 IOPS, 200 megabytes per second. And then I'd like to put my tempdb on local storage. The cool thing about putting tempdb on the local storage is it doesn't count towards your remote IOPS and throughput. So you can get all of that IO against tempdb, not counting towards your remote throughput against the VM, and it's SSD, it's fast. So this is a great place for tempdb. So if you do this, we will move tempdb to the local drive for you. And we also actually create a scheduled tasks that helps us manage that, because one thing to note with VMs that you might not be aware of, the local drive is ephemeral, which means when the virtual machine restarts, that disk and everything on it goes away. So when you come back, tempdb files are going to be gone. Well, that's fine, because if the VM is restarting, SQL Server is going to restart and tempdb is going to go away anyway. So it's a great way to leverage that local storage. However, we need a job to recreate the folder where those files are going. So this storage configuration will do all of that work for you. If you were to do this manually, we have an article that you have to follow and all the steps you'd have to execute to do that yourself. So this is nice because we do all that for you. So the last thing I want to point out with this storage configuration is you might note circled in red here, we actually have a little warning. And it's telling you that the desired performance might not be reached due to the maximum virtual machine disk performance cap. The selected VM size supports up to 12,800 disk max IOPS and 192 disk max throughput. But you can see with the disks that I've chosen, I'm actually allocating more IOPS and throughput than the VM can handle. So what I'm warning you right here is that you may not get this full capacity because you may be capped at the VM level. So you can either go back and choose a larger VM size, or you can reduce the number of disks you're choosing here, or you can say to yourself, well, actually, most of that IOPS and throughput is against my data drives, and I believe that I'll be able to leverage that read-only caching, and I think I'm going to be okay. So we're just kind of warning you of that. Once you click OK here and we build this VM, we will set the caching for you. We will move tempdb to that local drive. We will set up a job to make sure that tempdb folder gets recreated. We will move your data and log files to the appropriate data and log. All of this gets done for you. So it just saves a huge amount of time, and it makes sure that you're getting configured according to best practices. Okay, so let's summarize everything we've talked about. Choosing the right VM size, IOPS and throughput testing is the key. So remember I told you, you haven't been sizing your IO like this normally when you're on-prem. So you really have to think about this a different way. So when you're migrating to Azure, you need to collect this information from your existing on-prem workload so that you can choose the right target VM size when you migrate. So you want to collect your peak IOPS and throughput for data log and TempDB separately, since you're going to configure those devices separately in Azure. Then you want to choose the VM size that can scale to the total IOPS requirement. So you want to consider those cached IO limits for your data and TempDB reads, because those are the ones that are going to be able to leverage that read-only caching. And then you want to consider your uncached IO limits for log reads, writes, and data writes. Those are the IOs that are not going to be able to leverage the read-only caching. So look at those numbers and try to arrive at a combination of VM cap and disk capping that will allow you to scale to the needs of the workload. Make sure when you choose a VM size that you choose a VM size that has local SSD, because not all VM sizes have that. Those M series and E series ones do. Some of the L series ones might not, or some of the other general purpose ones might not have that local SSD. So make sure you have that local SSD so that you can do host caching and so that you can move TempDB there. Remember to use read-only caching. So if you don't use a marketplace image, then you got to make sure to enable that read-only caching yourself on premium SSD for your data files. And then if you can use the Ultra SSD, there's some region restrictions there, but if you can use it, it's great for the log file. And then over time, if you're monitoring performance and you're finding IO bottlenecks, you can consider upgrading the data files to Ultra SSD as well. Okay. Now, how much you're going to be able to leverage that Azure Blob Cache, that's going to vary by workload. We see most SQL Server workloads can make heavy use of that read-only caching, but you really want to do some testing to make sure that the sizes that you choose work for your workloads. And you want to make sure when you're doing that testing that you also run through things like index maintenance and backups, because those tend to drive up your IOPS and throughput for a short period of time. Now, if all that seems really overwhelming and you're not sure where to start, I do recommend that you take a look at the Azure Migrate tool. Azure Migrate will help you do this assessment that we talked about, and it will help you choose an appropriate VM size. In fact, it'll help you collect all the data you need to collect. It will analyze that data, and then it will recommend VM sizes based on your on-prem workload. So this is a nice, easy way for you to migrate with high confidence, leveraging all of the information that I just talked about and having this automated tool do some of that analysis for you. And last but not least, for performance, just a last performance checklist. If I were delivering this session to you in person, I would say this is the photo slide where you get out your cell phone and take a photo of the slide so you can remember it. So this is a checklist to just kind of keep in your mind as you're building your Azure VMs. So you want to ensure that you have the right VM size to avoid any disk capping. If the amount of IO that you're driving hits that cap limit either at the VM level or at the disk level, you are going to have some performance issues. You're going to start seeing IO latency, and that's going to slow down your workloads. So you want to make sure that you have a VM size large enough to avoid that capping. For the storage configuration, one more time on the storage configuration. So one thing, keep the storage account and the SQL Server VM in the same region and disable geo redundancy, because that can slow things down a little bit. Remember, data files on premium SSD with read-only caching enabled. And just a quick note there, there's different sizes of disks, P30, P40, P50. The larger you go with the disks, the more IO and throughput you get. However, once you get beyond 4 terabytes, you cannot turn on the read-only caching. So you need to be less than 4 terabytes. So you might do better having a pool with a larger number of small disks rather than upsizing to a single or 2 large disks. Okay, so usually you're better off with striping across smaller disks. So as I said, use storage pools with disk striping to achieve your data IOPS requirement. Remember, when you set up that storage pool, that the column count for the storage pool needs to match the number of drives in the pool in order to take full advantage of the IOPS and throughput across all the drives. Also keep in mind, if you add drives later, you need to recreate the storage pool if you want to actually add IOPS and throughput. Otherwise, you're only adding additional capacity because that column count is fixed. You cannot change the column count after the storage pool has been created. So try to do as much of this up front as you can. Make sure you're doing good monitoring so that you know you're getting the right number of IOPS. Place TempDB on local SSD, provision Ultra SSD only for the log file. There is also something called Write Accelerator. So if you're not able to use Ultra Disk, but you need a more boost in performance on the log drive, you can try Write Accelerator. The thing with Write Accelerator is it's only available on those M series VMs. So unless you're using an M series VM, that might not be an option. As far as SQL Server configuration goes, this is the same SQL Server you're running on-prem. So it's not really that much different in Azure as it is on-prem. So you want to think about enabling database page compression. That's something that a lot of people don't think about doing on-prem, but it can really reduce the amount of I/O that's generated by the system, and it can also shrink that I/O footprint. So that can help you a lot once you get to Azure when you're paying for IOPS and throughput upfront. Enable instant file initialization for your data files, limit auto growth. Again, anything that's going to generate more I/O, we want to avoid that. Enable lock pages in memory. This is also very important in a VM situation, but also especially if you have a large amount of memory, lock pages in memory becomes more important. And if you are on SQL Server 2019 or later, enable accelerated database recovery. Other than that, it's the SQL Server you know and love. It's just running in a different environment. Okay, so let's just quickly talk about a couple of backup options in Azure. I don't want to spend too much time because I want Aditya to have time to talk about HRDR. But for backup in Azure VM, you essentially have two options. You have, well, I guess I should say three options. You have automated backup, which is what's built into the IaaS extension into the portal, as Aditya was showing you. And this is essentially just a portal interface for the managed backup that exists already in SQL Server. So what this does is it just configures SQL agent jobs to manage backups for you, and it gives you a portal interface to be able to manage all of that. It's very basic. You can do point-in-time restore, but there's no long-term backup retention. You can only go up to 30 days. It doesn't have built-in support for availability groups, so we can't honor availability group configuration, like only backing up on the secondary, for example. But it does allow you to do things manually with scripting if you like. And automated backup is free. All you have to do is install the IaaS extension in full mode, and you can leverage automated backup. Azure Backup for SQL Server is another service that's offered in Azure, and this is a paid service. However, this is a much more robust enterprise backup solution. This really meets all your needs for backup. So if you're using a third-party backup utility on-prem, then this is probably the closest to what you would have on-prem with Azure Backup. I'll talk a little bit more about Azure Backup in a second. And then manual backup. Obviously, whatever you're doing on-prem, you can just keep doing it once you get into Azure. If you have your own jobs and you're happy with those jobs, you can continue to use them. There are many third parties that also work against Azure VM, so you might be able to just continue using the same vendor that you're using, or just do your own thing. It's up to you how you want to leverage, either leverage the tools available to you in Azure or continuing doing your own thing. So just a couple more things about Azure Backup. So one is this is available for SQL Server 2008 and later, whereas automated backup only works in 2014 or higher. This also supports up through SQL Server 2019. It offers no infrastructure for you to maintain whatsoever. You just enroll in the Azure Backup service and it starts working. It provides long-term retention if you need it, 15-minute RPO, point-in-time restores. The other cool thing about this is if you're managing a large number of VMs, this allows you central monitoring for all your backups. And it's not just for SQL Server. There are other products that Azure Backup supports. So you can back up your entire Azure VM estate using Azure Backup and then just have a single management plane for all of that. And you can restore anywhere. You can restore directly from the Recovery Services Vault. This uses a Recovery Services Vault as a backend. You can restore directly to the original virtual machine where the backup was taken, or you can choose another target virtual machine. Or if you want to take that backup somewhere else, like let's say you want to take it back on-prem for testing or development purposes, you can restore as files, and then that'll restore it to a BAK file, and you can take that anywhere you need. These are just regular SQL Server backups, so they're compatible anywhere that you're running SQL Server. So this is a great enterprise solution for managing backups in Azure VMs. And now I'd like to hand it off back to Aditya, who's going to take us to the end with high availability and disaster recovery options in Azure VMs.
Thanks a lot, Pam. That's amazing information. So everyone, if you're feeling overwhelming, please take a deep breath and don't take much time there because we are going to cover a lot of other information right now. So we spoke about how to run SQL Server on Azure virtual machines, the IaaS extension. Pam covered a great deal of performance. Now, let's also talk about how to configure high availability and disaster recovery. So, like, I know most of you guys are extremely well versed with SQL Server, and you know all of these features or all of these options to turn your high availability disaster recovery. So the SQL Server technologies, HRDR technology for Azure VM today, right now, are you can configure your failure cluster instances. You can configure your always on availability groups. You can also configure your log shipping. You can just take a backup of your SQL Server, restore with, and put it into the Azure Blob service. So the database mirroring, it's deprecated in SQL Server 2016. But for always availability groups, log shipping, and SQL Server backup and restore, these are extremely good for lift and shift, as you all know why, right? So, okay, so let's talk about few redundancy options that we have for Azure virtual machines, right? So there is this availability sets and availability zones. I will talk to you why am I talking about this very quickly. Availability set is having fault domains and update domains in the same Azure data center in the Azure region, and availability zones is configuring available in the same region. You have different data centers and you call each data center as an availability zone. So you have to make sure that you are configuring your HRDR solutions with keeping this in mind, because in Azure, because if you configure your SQL Server through availability sets, through availability zones, that will make sure your availability rate increases, because there will be times where Azure would be doing patching, taking the VM down for some reason which we don't know. Because of that, if you make sure that you are tying with availability sets and availability zones, you would guarantee your uptime of your SQL Server. Now, how to create SQL Server failover instances? So in Azure, there are multiple ways of creating SQL Server failover instances in Azure, and we from a product group are continuously working to make these things pretty easy. To start with, you can configure your SQL Server failover instance by using a premium file share. You understand premium file share, right? So it is fully managed file storage up to 100 terabytes. It's burstable performance, and you can link your Active Directory accounts directly to it. And I have added a link here such that you can go understand step-by-step process of doing it. So the basic reason that you would use it is it lowers the work on your virtual machines, because the input and output of your IOs is offloaded to the premium file share. So you configure premium file share, on top of it you configure virtual machines and you create a failover cluster instance. That's one option. The second option, there is S2D storage spaces direct, which is a Windows Server 2016 plus feature where you can configure storage on its own machines, virtual machines, and you can configure its storage spaces direct. On top of that, you need to configure failover cluster instance. So to configure failover cluster instance using a shared storage look-like architecture called S2D, you need to first configure storage spaces direct. On top of that, you have to configure your failover cluster instance. So so S2D has its own pros, but the cons is it requires high maintenance because as I mentioned, you have to build your storage spaces there first, and on top of it, failure cluster instance, on top of it, Azure load balancer. So we have looked at it and we said, hey, we can do this better. Then we came up with this. So it feels like you are on-prem. You have Azure Shared Disk. It's extremely easy to configure. All you need to do is you need to make sure that you are creating a P30, P30 or P40, whatever you take. You mark it as shared disk, and you need to give on how many virtual machines you're configuring this shared disk, and we will take care of that shared disk act as your SAN that is out there in your on-prem. So I have linked that also in how to configure that step-by-step tutorial, which is pretty informative in here. Now, bringing all the story together and to see what is good when. For performance and availability, which when I say, because I'm saying performance because you have to when you want to configure your servers for performance and availability, you need to choose your VMs, and that VM should be there in same availability set, and you can configure your always on availability group in the synchronous replication, because it is not so far. It will be extremely easy to send the data to the other VM, and you can configure your SQL Server failure cluster instance with S2D or PFS if you are in the same availability set. But if you want to optimize for manageability, you can put your data into Azure Shared Disk on Ultra SSD, and you can configure an SQL Server failover instance. Now, to configure it for resiliency, you might need to choose multiple availability zones and configure it with synchronous replication, or you can configure your failover cluster instance on a premium file share. Now, so FCI is a story like everyone, all the DBAs like us would love FCIs. The other feature that is there, and it is extremely useful for read-only workloads and making your scale-out workload in SQL Server is always on availability groups. And you can configure always on availability groups. As I was mentioning in my previous demo, we are building a high availability preview. You can right now it's in preview mode. You can go and you can play with it here, and we accept the feedback, happily accepting the feedback right now. And that's using the Azure portal. You can configure that using our Azure CLI. Everything what I'm talking right now is there in this tutorial. That tutorial is there in the link, and you can also quickly deploy your always on availability groups in using ARM templates. Now, coming to the other thing that we have newly introduced, right? That is called distributed network names. So if you want to create before distributed network names, if you have to create a FCI, the way the IP point really works, you have to configure a Azure load balancer on top of FCI to make sure to tell where you should point your who is the primary or who is the secondary, and that has pretty much disadvantages because there is extreme amount of maintenance. There is latency because you need to go through multiple hops, Azure load balancer, then the VNN, then the storage space and all that. So we kind of took it and we kind of made it simple by introducing distributed network names where you need not configure Azure load balancer. This entire aspect is gone, and you can just configure distributed network names. If you configure DNN, it almost acts as, and it's pretty fast. It's pretty good feature. You should really give it a try. But the only gotcha here is it is available from SQL Server 2019 CU2 and above. So that's that's the latest version has this distributed network names. So that's pretty much about it. And I will hand over this to Pam right now.
Awesome. Thanks, Aditya. So thanks everybody for joining us today. We will remain here for Q&A for as long as you need after our session. And our call to action is to have you take a look at migrating your data to SQL Server on Azure virtual machines. We've got a couple of links here. One is to the migration guide for SQL Server. And also, if you already are running SQL Server virtual machines in Azure, we encourage you to register with the SQL IaaS Agent Extension by doing the automatic registration that we talked about. A link here for that so that you can take full advantage of all of the features in Azure when you're running SQL Server and Azure virtual machines. Thanks very much for joining us today. Let us know if you have any questions.
Thank you, guys. Thanks for being awesome audience.
And enjoy the rest of your DPS.
Yeah. Thank you.